Hello viewers, in today's class we are going to discuss one important conceptual integral involving signum function, right? So here we have to integrate this function signum of x square minus 3x plus 2 from minus 2 to 3, right? So let us start. Now here we see that this expression is a quadratic function, right? So here let us take y is equal to x square minus 3x plus 2, which is a quadratic polynomial, right? Now let us split, or let us factorize this quadratic polynomial by splitting the middle term. So we can write x square minus 2x minus x plus 2. So we have x minus 2 minus 1 x minus 2. So we have x minus 1 and x minus 2, right? Okay, now if we solve the equation y is equal to 0, it means we have to solve x minus 1 times x minus 2 is equal to 0. So we have x is equal to 1 and x is equal to 2, right? Okay, so now if we take the real number line, then we see that x lies somewhere here and 2 lies somewhere here, right? And from the theory of increasing and decreasing functions, we know that x is equal to 1 and 2 divides this real number line into 3 intervals. The first one is from 2 to infinity, and the second one is from 1 to 2, and the third one is from minus infinity to 1, right? So here this quadratic polynomial has 2 roots. So this real number line is divided into 2 plus 1, that is 3 intervals, right? And since this function, that is x minus 1 x minus 2, is of the form k times x minus alpha x minus beta, where k is 1 and it is greater than 0, that is a positive number. So therefore we have to start from positive sign. So here we have positive, then we have negative, and then we have positive, right? So when x belongs to 2 to infinity, then this expression, that is y is equal to x minus 1 x minus 2 is greater than 0, right? Or when x belongs to 1 to 2, then y is less than 0, and when x belongs to minus infinity to minus 1, minus infinity to 1, then y is again greater than 0. Or we can say that y is positive in the interval 2 to infinity, and here y is negative when x lies between 1 and 2, and y is again positive when x lies between minus infinity to 1, right? We can also verify these signs by taking some particular values also, right? So we are not going to discuss the detailed method how to arrive at these signs, but let me verify by taking some particular values. So between 2 and infinity, we have x is equal to 3. So we see that y is equal to x minus 1 x minus 2. So we have 3 minus 1 and 3 minus 2, that is 2 times 1, which is a positive quantity, right? And if we take this interval 1 to 2, and if I take a value, say 1.5, then the value of y is 1.5 minus 1 and 1.5 minus 2. So we see that 1.5 minus 1 is positive and 1.5 minus 2 is negative, and the product is negative, right, which is this. And similarly, when we take a number between minus infinity to 1, say x is equal to 0, then y is 0 minus 1, and here we have 0 minus 2, so we have minus 1, and here we have minus 2. Minus 1 multiplied minus 2 is plus 2, and so this is a positive number, right? So once we have established that the sign of this function y in these three intervals, we can now easily integrate this function. So now viewers, let us take the definition of signum function. So signum of x square minus 3x plus 2 is equal to signum of y, right? And signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0. And what is y? Y is x minus 1 times x minus 2, right? And we have just seen that in this interval from minus infinity to 1, y is greater than 0, and here from 1 to 2 y is less than 0, and from 2 to infinity we have y is greater than 0, right? And the breaking point, or the points where we have to break the integral, are 1 and 2, where x is equal to 1 and 2 are the roots of x square minus 3x plus 2, right? So now viewers, let us come to the integral, right? So here the given integral is I, and we have to integrate it from minus 2 to 3, right? And see, minus 2 lies somewhere here, right? So minus 2 lies somewhere here, and 3 lies somewhere here, right? Now what we will do, we'll split this integral into the sum of three integrals, right? So I1 is from minus 2 to 1, and signum of y, right? And here I2 is from 1 to 2, and here we have 1 to 2, signum of y dx, and then we have the third integral from 2 to 1, right? So here we have signum of y dx. So y is given by x minus 1 times x minus 2, right? So I1 is from minus 2 to 1, I2 is from 1 to 2, and I3 is from 2 to 1, right? So now in the interval minus 2 to 1, we see that y is greater than 0, and whenever y is greater than 0, signum of y will take value plus 1, right? So we have minus 2 to 1, and here we have plus 1 dx, right? And when x lies between 1 and 2, we see that y is greater than y is less than 0, and whenever y is less than 0, signum of y will take minus 1 value, right? And when x lies between 2 and 1, here we have 2 to 3, right? So here we'll have 2 to 3, and here we'll have 2 to 3. So when x lies between 2 to 3, we see that y is greater than 0, and whenever y is greater than 0, signum of y will take a positive value, right? So here we have plus 1, right? Okay, so now we have these three simple integrals, so we can write minus 2 to 1 dx. Here we have minus 1 to 2 dx, and now we have 2 to 3 dx, and we know that the integral of dx is simply x. So now we have x, and limits are from minus 2 to 1. Here we have x, limits are from 1 to 2, and here we have x, limits are from 2 to 3, right? And now we have 1 minus 2, and here we have 2 minus 1, and here we have 3 minus 2, and therefore I is equal to minus minus plus, so 1 plus 2 is 3, and here we have 2 minus 1 1, and here we have 3 minus 2 is 1, right? So this and this get cancelled, so we are left with only 3, right? So the value of this integral is 3.